Hello, my name is Balraj Jutla. This is for Engineering 1166. Our project is based on a reinforced cantilever retaining wall. This is a sample of how the wall is supposed to look like. What is a cantilever retaining wall? Here's a sample of a 2D measurement of how the wall is supposed to look like. This is the earth fill. This is what it's supposed to keep in place or away from the other side. Here's the hill slab, toe slab, and then the stem. Cantilever retaining walls are constructed of reinforced concrete. They consist of relatively thin stem and base slab lined with steel or other reinforcing materials within the concrete. The base is divided into two parts, the heel and toe. The heel is the part of the base under the backfill to prevent sliding or overturning. The cantilever retaining walls are the most common type of earth retaining structure created from these three concretes: reinforced concrete, precast concrete, and pre-stressed concrete. This requires less concrete than other walls because it will be economical under 10 meters. How does it work, you may ask? This retains different levels of the surface from collapsing or washing out from elevated positions. The cantilever retaining wall works on the principles of the leverage to stay in place. It has much thinner stem and utilizes the weight of the backfill soil to provide the most of the resistance to sliding and overturning. The reinforcement in some designs increases strength of concrete when necessary. There are 9 types of multiple wall structure platforms such as gravity, crib, gabion, cantilever, counterfort, buttressed, anchored, piled, mechanically stabilized earth, or MSE, and hybrid systems retaining walls.
Harder now. How are they created and the supplies used? The supplies used in them are made of high strength concrete to combat things like erosion and weathering. This just increases the strength that it has against natural forces of the earth. There are steel rods that run through these structures. They go both laterally and horizontally, vertically, to resist the force that applies to them, adding more strength to what is just the concrete itself. These can be assembled off-site or on-site, so this can be poured into concrete sections and stabilized so that way they're created on their own with other sources, or they can be made off-site at construction or masonry plants where then they would be shipped to location on a truck or trailer. However, in our design, we did not choose to do this as it's not as cost efficient. They come in many different sizes. You can see them as small as several feet tall for landscaping applications, as well as up to several stories high in things like high rises or bigger highway jumps like in our example that we're going to use. Our retaining walls design and dimensions. So our location that we chose is going to be in Connecticut. This is mostly consistent of a clay and silt based soil complex around here. Maybe a little bit more sandier if you go towards the shoreline or other parts of Connecticut, but typically that's the kind of soil that you see around here. The dimensions that we went with are a 2 by 7 meter tall, 4 meters deep for the top half of the upper slab that connects to a 6 by 1 by 4. So if you think about it as 2 boxes that are somewhat thin, just connected on the same base, this will be connected 2 meters in from the toe side, giving it the longer side underneath the backfill for the strength against sliding and overturning. The purpose of this wall in this application will be to prevent rock slide into a valley, probably to heighten from a highway or other higher level elevation of soil to prevent any sort of landslides from occurring and retain that soil in place from where it is. This will prevent people using the roadway from being in some sort of an incident or something occurring from natural weather around the area. This will be cast in place design for our use. This is the most cost efficient way to do it in most scenarios, as well as because it's A reinforced cantilever wall, it adds a lot more weight and size in our dimensions, therefore transportation isn't, as stated before, really economical, as you have to have permits to move oversized loads, as well as just the gas and fees we have to pay to move it around. This will be using a regular backfill, as the soil is assumed to be above the water table, so you don't need a lighter weight or more absorbent type of backfill. You can use more of a traditional generic type of backfill. Its location doesn't warrant any sort of advancement in seismic measures and designs. Around here we don't have any sort of things like that for earthquake accidents or anything around those. Typical, it's just weather and cold winters that we have to deal with. So the calculations that we got in our design, the assumptions that we went with are that there's no surcharge on the top, that meaning there's no bridge connecting to the top half to push down on it. It's just simply a gravity effect that's occurring, as well as the force horizontally against the backside of the wall. There's a frost line that will be right at the level of the bottom heel of the lower slab, and this will be above the water table as stated before, so that way there won't be as much saturated soil or contractions of the soil based on temperatures and things related to that. The calculated lateral earth pressure that we found on our wall was 803.81 pounds per cubic foot of force. This was for typical soil around here consisting of clay and silt. The point of sliding that we found was 10,548.63 pounds per cubic foot. This in yield would be a 6.2 times factor of safety, which is a much higher safety factor than is needed, therefore reduces its economical footprint, but is still on the very, very safe side. The overturning point would be 92,350.55 pounds per cubic foot, and this again would also give a 13.74 factor of safety. Again, high, but very safe in the long run for its economical use.
So what materials are required for the construction of the cantilever wall? For our wall, we chose reinforced concrete, number 5, high strength epoxy coated steel rebar, which is more resistant to corrosion, a granular regular backfill for drainage, and soil from the location. Our materials are chosen to prevent things like corrosion, cracking, sliding, overturning, and soil burning. This shows a picture of the steel rebar placement before concrete is poured. And the construction of the wall itself is started from the bottom horizontal base, and then the vertical top base is constructed. So what is the cost of the cantilever wall? The cost of reinforced concrete is $16.55 per cubic foot, and the total volume of our wall is 262.467 cubic feet. So the total cost of reinforced concrete is $4,343.82. And the cost of rebar is $2.55 per pound. And the amount of rebar required is 1,197.87 feet, which is roughly about a foot weighing about 1 pound. And the total amount of rebar required is 1,203.02 pounds. So the cost for rebar is $3,067.70. The total cost of the cantilever wall itself is $7,411.52, and this is excluding labor.
This is an example of a retaining wall. It has steel reinforcement, a 2-inch weep hole, drainage mat with a filter fabric, porous backfill, 2-inch minimum cover, perforated drain pipe, which is usually included in them, but we didn't include one in ours, and a 3-inch minimum cover. Now we're going to look at if we could make it less expensive but keep the safety. Greatly, our safety is far beyond the requirements, to which it is no longer economical. Cost of supplies also fluctuates. Concrete and steel rebar prices change over time based on the market demand. Innovations of design and material may also alter the cost of safety. As material becomes less expensive, the safety should remain to standards. And then here are the problems we encountered in the design. Time constraints, the knowledge of the dynamic design functions, having no initial parameters for dimensions, changing water table in the soil, weather, and erosion, finding accurate pricing and calculations, and finally knowing the expected lifespan of the retaining